Next problem we'll try to solve merge k sorted lists. What it means is the lists are already sorted and we need to merge into one list. That is the basic idea of the problem. We can solve this problem with two different approaches. Basically, let us understand. I took some small, simple lists which are 1, 4, 2, 5, 3, 6. So for this case, actually, we have two approaches as I mentioned. There is a brute force. Basically, brute force approach is that it's simple. Um, so what we need to do is we need to create one slice with all these numbers, right? Just push all the numbers into this. Okay. After that, just sort them with two and log(n) time complexity. Basically, this will be after sorting. This will be like this, and just return this. That's it. This is the brute force, and this is not an efficient one. This time complexity will be like for sorting. This is n log n, and also space complexity because we need to store all these numbers in a slice. That is again space will be of n time complexity. So basically, we using there is an optimized solution for this. We can use the priority queue, like optimized solution. That is, you can use the priority queue, and then we can try to solve that. That will be taking the time complexity of basically n log k. That is actually k is nothing but number of lists. Currently, in this case, actually we have 3 lists. That is the k here. And yeah, space will be like O of k. Basically, we can use the priority queue to store how many number of lists we have, that many numbers basically. So I have taken one, I prepared one PPT to explain this in a different manner. So basically, like let's take this one. So initially, what we can do is in the min heap we can push all the elements of the start of the elements. In this case, actually, I will push 3 lists of start element. That is like I0, I0, I0 of these elements. That is actually 1, 2, and 3 will be there. And merge list, like a result will be like a empty initially. Okay. Next step, actually, what we can pop the min heap first element earlier. That is actually you see 1. We can push that element to the returned merge list, and then you can see that the first element will be deleted from the list. Actually, we processed that, right? And then next element will be like this element we are trying to push here into the min heap, and then it will be reordered automatically because it will be in a minimum to maximum. Next step will be next iteration. We can push the top element, like a minimum element. We can pop that element and we can push that into the merge list, and that will be like removed from the second list first element. And next step will be we can try to push the next element, that is 3, from the third list of the first element. Similarly, now we have 4, 5, 6, and this is the order. And next we can remove the pop the min. Actually, it will be 4. We can push that 4 into the return value. And then we have 2 values here. One list already processed everything. Next list. And you can pop that element and push it. Now all the lists are processed, and min heap also become empty. Nothing to process now. So return values will be like on this order, and it is all sorted order. So this, as I mentioned here, this time complexity of this will be like a O of n log k, and space will be like a O of k. So I think brute force is very straightforward. I don't want to write that solution because we are simply creating slice and dumping everything there. I will try to explain the optimized solution using a min heap thing. For that, we can try to implement. We can use the heap, and then we can try to solve that. So yeah. We can create one node heap, uh, of type list node, whatever the list node we have already in this structure, right? So yeah, and then we can implement few functions where the interface has the few things to be adopted. Can use func node heap, okay, let's get the length of it. Sorry. And then it will be returning length of integer, just length of node pointer. Let me copy paste this thing here. Instead of typing multiple times, I will just try to copy and paste these things for different functions purpose. So basically we need length and something called less, because this will be helpful for us to comparison purpose. So this will be written in bool, and this boolean will be returned in case of nh of I dot val is less than nh of j val. Val is actually from the structure. Okay, that is one thing. Another thing is basically we need to swap also. Swapping also we need to override. Nothing to return here, but we'll simply swap the things. Okay, nh of I comma nh of j is equal to nh of j nh of I. Right? We are simply swapping them, and then we'll write one more method to push the elements. Func nh node heap, just push some element. Let us take this as an interface. Right, now we can try to see nh equal to append into that slice, whatever we are trying to do that. This will be of type list node, right? That's it. Now let us see that the pop functionality, or how we can implement func node heap can pop that interface. Okay, this we can just take the old one out first. nh and length, we know length of old one, right, before changing anything. The return value old of length minus 1, and we can just make nh will be equal to old of start from 0 to length minus 1. Okay, and then return the popped one. Okay, that's about that. And coming to this one, actually we can try to create a heap of node list, and we need that. Just initialize this one. Now what we need to do is, as we discussed in the diagram, that we'll try to take each list from the range of lists, check that if list is not equal to nil, just push into the heap that list, right? So we are just pushing all the lists actually like this, as I mentioned. We are pushing all the things into this list actually. Okay, that's what the line I am writing here. This one, this for loop do like that. Now, okay, now I have listed everything. Then we will try to see some list node for dummy purpose, and then we can make this as a current, and then we'll try to see that you need to just traverse everything till this particular heap, min heap become min heap length become 0. Basically you need to process everything. Okay, so here actually one small element that will be on top of the heap, that is dot pop of the heap whatever we created, and this we can convert into list node, right? So this one actually we can try to attach that into next. Current next is equal to this particular small one, actually smallest at that point of time, right? And then this current we can move next, right? And then if you see that if this small next is not equal to nil, then we need to push this heap next element, right? Dot push of this particular node into small dot next element we are pushing there, so that we can keep iterating this until you process all the elements in the list, and then we just return the dummy dot next. Basically dummy, we just took the first node as empty, then we are trying to let's run this and see any problems, compilation issues or something is there. Okay, undefined I and j. Okay, undefined I, line number 43. Undefined I, where is I? Didn't use any I here, right? Okay, what is this? I got it. I comma j. This is actually index. Sorry for that. And I comma j. Type integer. Okay. Let us see now what happens. Undefined node list. Oh, this is list node. Sorry. List node. Yeah. Okay, let me see this will work or not. Okay, cannot use h variable. Cannot use h variable. Oh, sorry. Basically, we need to use this. This is actually. Oops. Yeah, these things generally happens. Okay, let us see what happens. Yep, this works. And as also I'll discuss, this will be the time complexity will be O of n log k, and the space will be this. That's it. Let us submit this and see what happens. This is one of the important question during interview.